Welcome to BTEC Revision. In today's lesson, we're looking at resistance in series and parallel circuits. By the end, we should be able to calculate the resistance of components in both series and parallel circuits. Let's start by looking at what a series circuit is. A series circuit is one in which all the components are arranged in a single path. So this means that if we take a look in the diagram below, you can see that the electrons or charges are moving around and there are no other paths. They have to follow the one path. So another way to look at series circuit would be a single loop. Since the charge has no other path to flow, the current must remain the same in series circuits. However, the voltage would change. For example, if we take a look at this circuit, we have a battery. Let's say it's 10 volts, and it's connected in series with two 100 ohm resistors. Now, this voltage is going to be shared in this case equally because the resistances are equal. Therefore, this resistor on the left will receive 5 volts and the resistor on the right will also receive 5 volts. If we add these together, that would give us 10 volts, which is the voltage of the battery. How do resistors behave in series circuits? Well, let's have a think. If we have electrons and they are flowing in the circuit, then as they are flowing through the first resistor, they will experience 100 ohms of resistance. And as they go through the second, they will experience another 100 ohms of resistance. So in total, we can add them up to give us a value of 200 ohms. Therefore, we can say that the resistance in series circuits adds up, and it's given by this equation. RT, which stands for the total resistance in the circuit, is equal to resistance 1 plus resistance 2 plus so on, depending on how many resistors there are in the circuit. So in this case, we have a total resistance in the circuit equal to 100 ohms plus 100 ohms, which gives us a value of 200 ohms. So effectively, we can redraw this circuit with the cell as before, and we can replace these two resistors with one big 200 ohm resistor. So these two circuits are equal. Now, let's take a look at this example. Given three resistors with values R1 equals 220 ohms, R2 equals 330 ohms, and R3 equals 470 ohms, connected in series, calculate the total resistance of the circuit. So what we can do is write down our equation, RT equals R1 plus R2, and in this case, there are three resistors, so that's plus R3. And we can plug in the values. So that's 220 plus 330 plus 470. And let's calculate this. It's a value of 1020 ohms. Coming back to our previous example here, we can link in a previous lesson on Ohm's law. And if you remember, that's V is proportional to I. If we multiply this by a constant, we get the equation V equals IR. So we can also use this in our lesson on resistance in series and parallel. Now, looking at these values, we've got 10 volts for the battery, and we have 100 ohm and 100 ohms. Now, we can work out the total resistance, which we have done before, which gives us a value of R equals 200 ohms, and we got a voltage, so we can work out the current. So current equals V over R, that is 10 over 200, which gives us a value of, so that would be 1 divided by 20, which is equal to 0.05 amps. Now we can look at how resistors behave in parallel circuits. But first of all, what is a parallel circuit? A parallel circuit is one in which all the components are arranged in two or more paths. Now, we can think logically how the resistance is going to behave in total. Well, if we take a look at electrons flowing in the circuit, they are going to have a choice at this place here. This place is called a junction. So this is a place where the electrons can choose another path. So if they are equal in resistance, then half of the electrons will flow through this way, and the other half will flow through the bottom path. So this would therefore effectively reduce the resistance experienced by a half. Another important point to note here is that the voltage is not shared, it is equal in the whole circuit. So for example, if we have a battery with a voltage of 10, then the resistors are also going to have 10 volts, and the last one is also going to have 10 volts. Thinking about the current here, as these electrons or charges are being split, then the current is going to change in this case. And in this case, it's going to reduce. So we can use this formula to calculate the resistance in parallel circuits. Here, 1 over RT, which is the total resistance, is equal to 1 over R1 plus 1 over R2 plus so on, depending upon how many resistors there are. So in this case, we can work out the total resistance by plugging in our values, which is 1 over 100 plus 1 over 100, which gives us a value of 2 over 100. And we can simplify this to 1 over 50. So we know 1 over the total resistance equals 1 over 50. So we can do a quick flip. The mathematical term for this is called the inverse. So that would give us a value RT equals 50 ohms. Now let's look at this example. Two resistors are connected in with a parallel circuit. The values of the resistors are R1 equals 150 ohms and R2 equals 200 ohms. Calculate the total resistance of the parallel circuit. Let's start down our equation. 1 over RT equals 1 over R1 plus 1 over R2. And we can plug in our values. 1 over 150 plus 1 over 200. Okay, and we can work this out, which is equal to 7 over 600. So this is equal to 1 over RT. So we can do the inverse, which gives us RT over 1, which is equal to 600 divided by 7. And that's equal to 85.7 ohms. Now pause the video here and attempt this exam question. A cell of 1.5 volts and resistors are connected in the circuit shown below. Calculate the potential difference across the resistor R. Let's start by looking at the circuit here. We've got a voltage 1.5, which is in the correct unit. We have three resistors. One is 0.5, which is in the correct unit, and the other two are in milliohms. So let's start by working out these values. So that would be 0.5 ohms, because if you replace 500 milli with 10 to the power minus 3, okay, that gives us 0.5. And same thing with the bottom one, so that would be 0.6 ohms. Now, it may get confusing as to which part of the circuit is series and which part is parallel. So if that happens, always think about the path of the electrons or charges. So as these electrons are flowing, they will all have to travel through this 0.5 ohm resistor. So therefore, this part here would be a series circuit. And at this point or junction, they would have to split. So some would go left, others would go down. So that would make these two in parallel connection with each other. So we can start by working out this resistance. So that would give us 1 over R, which is equal to 1 over 0.5 plus 1 over 0.6. And that gives us a value of 11 over 3. Now working out the resistance, R, that gives us 3 over 11, and that would be ohms. So we can simplify the circuit by drawing, instead of the parallel connection, we can replace that with one resistor, which has a value of 3 over 11 ohms, and we can finish off rest, which is a value of 0.5 ohms. Now these two resistors are in series, and that's easy. We can just add them up. So that's 3 divided by 11 plus 0.5, which gives us a total resistance in the circuit equal to 17 over 22 ohms. Now we have the total resistance and we have the total voltage in the circuit. Hopefully you can think which equation that would be. V equals IR, and we can rearrange that for I, and we know V is 1.5, and the resistance is 17 divided by 22. So 1.5 divided by our previous answer gives us a value of 33 over 17 amps, which is equal to 1.94 amps. And that's the end of the lesson. If you would like to boost your grades, try the quiz questions, and there's lots more resources at btechrevision.com. See you next lesson.